Today, let's take a closer look at this workpiece, step by step and with all the important G-codes. First, the outer contour of the workpiece is rough milled. Here, G41 is used, radius compensation left. This ensures that the machine does not follow the contour directly, but with an offset according to the tool radius. In this way, the contour remains accurate to size despite the tool diameter. G46 complements this by ensuring that the tool does not cut in abruptly, but enters the path smoothly, protecting both tool and workpiece and avoiding poor surface quality. The milling path starts at x0, y 2.5. From there, it follows a sequence of straight lines and circular arcs. And that's it? That went a bit too fast? Let's take a closer look. With G1, the tool first travels a straight line to the left. Since the Rn parameter is negative here, a chamfer is created at the end of this line. In other words, the corner is slightly beveled so that no sharp 90-degree angle remains. This is followed by a shorter straight line upwards. After that comes a series of circular arcs, clockwise and counterclockwise. The clockwise arcs are programmed with G2. The counterclockwise arcs are created via the Rn parameter. Wait a minute, Rn? Wasn't that a chamfer just now? Correct, but here Rn is positive. And with positive values, Rn does not create a chamfer but a rounding. In other words, a circular arc, in this case counterclockwise. Let's go through this step by step. First arc, G2 clockwise, programmed with I and J. Second arc, counterclockwise via Rn with a positive value. Third arc, again clockwise, G2, this time only with a fixed radius instead of I and J. This means the control automatically calculates from the radius value where and how the arc runs. Fourth arc, counterclockwise via Rn. Fifth arc, larger arc clockwise, again with I and J like the first arc. Sixth arc, again counterclockwise. Seventh arc, another radius arc clockwise. Eighth arc, one last time counterclockwise via Rn. And the final arc, clockwise with G2 and I and J. Finally, G1 travels straight down. Rn, now again with a negative value, creates another chamfer before the tool returns to the center with G1. With program repetition G23, the contour is then machined again, this time with a deeper depth of cut to reach the required final depth. Next, using the circular pocket milling cycle G73, a circular pocket is milled to a depth of 10 mm with a radius of 12 mm. This is followed by a crescent-shaped contour pocket, created with circular arcs, G2 and G3, and straight lines, G1. Inside this crescent pocket, 3 smaller rectangular pockets are then milled using the rectangular pocket cycle G72 in several passes, on a partial circle with a radius of 36 mm. Their orientation toward the circle center is 45 degrees each. G77 ensures the exact positioning on the partial circle. After that, all machined surfaces are finish milled to size in several passes. The 3 rectangular pockets are chamfered. Finally, 4 holes are prepared for M10 threads. After center drilling and countersinking, the thread is cut to a depth of 24.5 mm with a pitch of 1.5. And that's it. This is how many small lines add up to form a complete machining process.